Welcome back to our discussion of factoring polynomials. What we just did was factoring out greatest common factors, and I want to give you a hint that it, again, isn't exactly a matter of right or wrong. It's something that will make your life easier. We're going to review several techniques for factoring, but you should start every single factoring problem not with those other techniques, but by factoring out a greatest common factor if there is one. I often forget to mention that I'm doing that, so I will mentally look and see if there's a common factor, and if there's not one, I forget to mention to you guys that I did that mentally, but I do that every single time because first of all, I'm likely to forget to factor it out if I don't do it at the beginning, and second of all, there's lots of problems that are way harder if you don't start by factoring out the GCF. So always look for that first. Okay, that said, the technique we'll review is factoring by grouping, and I've got another hint for you right away, and that is that if you're trying to factor a polynomial that has 4 terms, you will usually factor by grouping. Now, sometimes you may need to rearrange the terms first. I'll just mention that right here. Okay, so factor 5x minus 55 plus xy minus 11y. I see there are 4 terms, so I immediately think, I'm probably going to factor by grouping. Now, grouping is where you make groups of the terms. So I'm going to group the first 2 terms separately from the second 2 terms, and I treat the 2 groups individually, separately. I ask myself, what if anything, can I factor out of the first group of 2 terms? And in this case, I answer myself 5. So I take out a 5. That leaves x minus 11. I go on, don't forget to put a plus here. I go on and ask myself, what can I take out of the second 2 terms? What's the GCF? And I answer myself, in this case, y. So I factor out a y. That leaves me x minus 11. And now I'm in one of those situations where I have a binomial common factor. So I have 5 times something plus y times the same thing. So I can undistribute that thing that had been distributed into 5 plus y. Okay, and there's my answer. And remember, you can always check your factorizations. So if I check, x times 5 is 5x, x times y is xy, minus 11 times 5 is minus 55, minus 11 times y is minus 11y. And that's the same thing I had up here. Yes, these 2 terms are written in a different order than they were up here, but it's the same polynomial. Okay, so that checks out, and we're good to go. Good to be done. Okay, so I know this is not the kind of thing you remember if you haven't done it in a while, so I do have a couple of more examples for you before I give you some to try out for yourself. And I did what I said I would probably always do. Let's just back up. Before I even started this, I mentally looked at the 4 terms to ask myself, is there a GCF for all 4? There wasn't, so I forgot to even mention that I had done that. In the next one, this time there is a GCF, so that's why I'm remembering to mention it. I look at all the terms, and I ask myself, is there a common factor for all of them? And there is, right? 2 goes into all of the coefficients. So I'm going to start out by taking out a 2. That'll give me xy minus 5y plus 3x minus 15. Okay, now I go on and say, let's see, I've got 4 terms, so I'm going to factor by grouping. Grouping again means that I look at the first 2 terms as their own little group, the second 2 terms as their own little group, and I ask myself, what can I take out of each group? I write down the 2 again so that I'm showing clear, complete work. The 2 doesn't just vanish. It comes along for the ride. Let's see, what can I take out of those xy minus 5y? Yeah, I can take out a y. That gives me x minus 5. I write down the plus. Ask myself, what can I take out of 3x minus 15? The GCF is 3, so I take that out. And I have an x minus 5 in both spots. So that can be taken out, undistributed, factored out from y plus 3. Before we go on, I want to point out that I really don't, in this line, I don't need these big parentheses, because with multiplication being associative, I don't need to say I'm grouping the x minus 5, or that I'm associating the x minus 5 with the y plus 3. So typically you'd see this written that way. However, I want to point out that in this line here, third line from the top, I need the big parentheses. So what would be different if I had just written, so if I didn't have them and I just had 2y x minus 5 plus 3 times x minus 5, what would be incorrect about that? Well, what this is saying is that the 2 is only a factor in this first spot where I have the y times x minus 5. So it's saying the 2 does not distribute into both spots, but I have 2y times x minus 5 and no 2's here. And that's not the case, right? This 2 came out of all of the terms. So this 2 is a factor that was multiplying everything, and that is what these large parentheses show. So you can use square brackets maybe to make it more distinct what's playing the role of what, but I need those big parentheses because the 2 came out of all of that stuff. Once you have it factored, though, the big parentheses are no longer playing that role, because basically what's going on there is 2 times, let's say, AB in parentheses like that is the same thing as 2AB like that. So just kind of in this theme that I keep bringing up, we have to be careful with our parentheses. Okay, let's try one more, and then I'll give you some to try. So y cubed plus 6y squared minus 4y minus 24. First I ask myself, is there a GCF for all the terms? But there's not. So I go on and make groups. Now be a little careful here. A lot of times what I see people do is, and this is another issue with parentheses, I'm going to rewrite the polynomial. So a lot of times what I see people do is make groups like this to do their grouping. And there's a problem there with that. What's the problem? So a lot of times, I didn't quite have room to do it up here, but a lot of times people just start out by doing that, and I understand that because that's what I was doing in the previous problems. But the issue here, the problem with this, what's wrong about this, is we are now saying y cubed plus 6y squared is multiplying minus 4y times minus 24, right? If you have two sets of parentheses next to each other with nothing in between them, you're saying this stuff's multiplying. And that's not what we had, right? We had y cubed plus 6y squared isn't multiplying anything. We're then subtracting stuff. So how would I fix that? Well, you've got to be sure when you do this to put a plus between the parentheses. Okay, so you can go ahead and right here, it's okay with me if you make the parentheses, but you've got to leave a little tiny bit of room for a plus to indicate that no, that stuff's not, it's not that these two terms are multiplying those two terms. We're adding some negative stuff. Okay, that said, we're just going back to our regular grouping. In the first group, I have y cubed plus 6y squared. What can I factor out? The GCF is y squared. So I'll take out a y squared. I'm left with a y plus 6. What can I take out here? I can take out a 4. But if I do that, notice I'll have minus y minus 6. And now I'm stuck. I can't go forward because I don't have the same stuff in the two sets of parentheses. So I don't have a common factor at this point. And hopefully you know that the fix for that is to, instead of taking out a positive 4, take out a negative 4. That'll leave me positive y, positive 6 inside the parentheses. So, you don't even need to go here if you knew to take out a negative. But I wanted to show you what would happen if you don't remember to take out a negative. And remind you that if you don't have the same things in those two sets of parentheses, you can't pull anything out. Sometimes people will from here pull out a y plus 6 and a minus y minus 6, but you can't do that. You have to have the same thing in both spots. Okay, but at this point we have the same thing in both spots, so I can pull it out or factor it out or undistribute it. So I have y plus 6 taken out of, undistributed from y squared minus 4. Am I done? I've got the right answer. I mean, my answer's correct. If I check this, I will find that, yeah, I have that still, just written as a product, written as a multiplication problem. Well, but actually I'm not quite done, because you're always, when you're asked to factor, you're always expected to break things down all the way. And y squared minus 4 actually factors. This is a difference of squares. This is going to factor as y minus 2, y plus 2. So my final answer would actually be y plus 6 times y minus 2, y plus 2. Okay, so it is your turn. I've got some 4-term polynomials for you to factor. Let's see, I've got, it looks like 4 problems for you to do. Which I believe are fairly similar to the ones I did. There might be some wrinkles in there that I didn't specifically review. But I'll leave you to these, and I'll go over them with you in the next video, and we'll talk about any problem spots that might have been in there. So good luck with those, and I'll see you in the next video.